Hi, welcome to my video on find the exact trig ratios of the special rotations, part 1, and the reference angle of 30 is in part 1. This is the first video on the unit circle in trig. And we're looking at when the reference angle of 30 degrees. The reference angle of 30 degrees. And I have a triangle here. Let's put this angle as 30. This angle is 60. And in the first unit, or one of the units on trig, on right triangular trig, we had special right triangles, and opposite the 30 was n, opposite the hypotenuse right angle. Opposite the right angle is the hypotenuse 2n, and opposite 60 was n root 3. And if we divide each of these sides by n, we would have a 2, a 1, and a root 3. So this triangle still has 30 and 60, so these two triangles are similar because the two pairs of corresponding angles are equal. Now if we take this triangle and divide by 2, 2 divided by 2 is 1, 1 divided by 2 is a half, and root 3 divided by 2 is root 3 over 2. And again, the angle is 30 and the angle is 60. Triangles are similar, but this is a special triangle. It's called the unit. And since we're dealing with what we call the unit circle has a radius of 1. So if I take this triangle and put it in this circle with a radius of 1, so that's the center of 0, 0. And if you make this distance here 1, then this point has the coordinates of 1, 0. So if we rotate 30 degrees, theta is 30, we could find the exact values of cos and sine of theta. So if we rotate 30 degrees up on this circle, and we draw a terminal arm going out through that where the rotation stops, we drop a right triangle to the x-axis, and this rotation is 30, so this angle in here is 30, and that means we have a 90, so this angle is 60. So opposite the 30 is a half. Opposite the 60 is root 3 over 2. And the hypotenuse of the triangle is 1, or the radius of the circle is 1. And when that happens, just to review, sine is opposite over hypotenuse, which is the y over the r. So the sine of 30 degrees is the y, which is a half over 1, so we have a half. And the cos of 30 is the adjacent over the hypotenuse, which is the x over the r, and the cos is root 3 over 2 divided by 1, which is root 3 over 2. And as you can see on this circle, let's go back and do a little bit of review on, because the hypotenuse is 1 on this unit circle, the cos of theta is x over r, and so that's x over 1, which is x. Because the hypotenuse, or the radius of the circle, is 1, then the cos is the x, and the sine of theta is the y over the r, which is y over 1, y. So on a unit circle, which has a radius of 1, cos is the x, sine is the y. On any other circle that don't have a radius of 1, you have to go x over r or y over r for cos and sine. So with a 30-degree rotation, we worked out the exact values. Now we have a rotation of 150 degrees. And so let's rotate again. This point right here is 1, 0, because the radius of the circle is 1. So this distance right here is 1 unit. When we rotate 150 degrees, here I go, that's 90 and 30 more. So that's a rotation of 150 degrees. We draw a terminal arm going out through from the origin, 0, 0. So that rotation is 150, and that means that, 150 degrees. So I didn't go far enough, and that would make this angle right here 30, because it's 180 plus 180 take away 150 is a 30 degree. Drop a perpendicular to the x-axis, and that is a 30, 90, so that's a 60. Opposite to 60 is root 3 over 2. Opposite to 30 is a half, and the radius of the circle is 1. But because we're in quadrant 2, then the y is positive and the x is negative. And I just want to go back to this right here. If this is on the unit circle, x is root 3 over 2, and the y is 1/2. And right here, the coordinates of this point, x is a negative root 3 over 2, and y is a half. So the cos of the 150 is the x over the r, remember, but it's the x over 1. So cos is the x. So the x is a negative root 3 over 2. And the sine of 150 is the y over r, y over 1 or y. And the y value is a half. So again, the cos is the x on the unit circle, which is a negative root 3 over 2. Sine is the y, which is a half. And I always draw the triangle and put in the reference angle. This is the reference angle. Even though the rotation is 150 degrees over the angle, when you set up the right triangle, it's the reference angle that determines the two ratios for the rotation. And again, notice this point 1, 0 is rotated to this position, and there's the two coordinates. And this point 1, 0 is rotated 30 degrees, so these are the coordinates. And let's continue. Find the value of cos and sine for each rotation. Now we have a 210. A 210, again, this is 0, 0. The radius of the circle is 1, so this point is 1, 0. Again, the point 1, 0 is rotated to 210. So that's a 90, 180 plus, and we have 210 minus 180, so we have a 30 degrees. So this is 30 degrees into here, and draw a terminal arm. So that's 210 degree rotation, and that's 180, and that's a 30. So we drop a perpendicular to the x-axis. So there's a 90, 30, this is a 60. Opposite to 30 is a half. Opposite to 60 is always root 3 over 2. When the reference angle is 30, these are the numbers. But because this is quadrant 3, x is negative, so it's a negative 3 over 2. The y going down is negative a half. So the coordinates of this point now, x is a negative root 3 over 2, and y is a negative a half. So the cos of the rotation 210 on the unit circle is the x, and the x is a negative root 3 over 2. And the sine of 210 on the unit circle, sine is the y, so it's a negative a half. Remember, cos is the adjacent over the hypotenuse, but the hypotenuse is 1. So putting root 3 over 2, negative root 3 over 2 divided by 1, gives you negative root 3 over 2. And the sine is opposite over hypotenuse, which is a negative a half over 1, which is negative half. Because, excuse me, on the unit circle, the radius is 1, the hypotenuse is 1. Again, cos, repeat, cos of theta on the unit circle is the x. The sine of theta on the unit circle is the y. And so we have cos and sine. Done. Negative root 3 over 2, negative a half. Now, again, this circle is 0, 0. Radius is 1. So we're rotating this terminal arm right around to 330 degrees. So it's a 90, 180, 270, and we're all the way in here at 330 degrees. So let's say it's about right there. So that's 330 degree rotation. We draw a terminal arm going out through, and we have 330. So what is this angle here? Well, all the way around, right around one rotation is 360. So if I take off 330, I have a 30 degree angle. So the reference angle again for this rotation is 30. Perpendicular to the x-axis, 30, 90. This angle is 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. But in this quadrant, which is quadrant 4, the x is positive and the y is negative. So the coordinates of this point, x is root 3 over 2 and y is negative a half. So the cos of 330 degree rotation is the x, which is root 3 over 2, and the sine of 330 degree rotation is the y, and the y is negative because it's in the fourth quadrant, negative a half. So that's 4 rotations, 1 in each quadrant. And based on that, let's put them all on, let's let the circle have a radius of 1. So that means this point is 1, 0. This point here, x is 0, y is 1. This point here, x is negative 1, y is 0. And this point here, x is 0, y is negative 1. And again, this is the coordinates of this the center of this circle. This is the center here, 0, 0. So if we rotate 30 degrees right here, and this is the 30 degree rotation, we get, I'm going to draw this. Now I'm going to show you something. I'm going to go right on through. So the 30 degree rotation is 30 degree angle. We drop a perpendicular, and I'm going to draw this on down. You're going to see something happening here. Now draw it on down, and I'm going to set up the 4 rotations that I just did all on one circle. So let's put all 4 rotations onto one circle. And we make what we call I call it a butterfly, or some people call it a bow tie. But when you rotate 30 degrees and you set up a right angle, this is 30 and this is 60. This is root 3 over 2. And this side is a half. So this point, x is root 3 over 2, y is 1/2. The x is positive and the y is positive. So when you rotate 150, which is from here, all the way around, right to here, this is the rotation of 150 at this point. This reference angle is still 30. This is a 90. That's a 60. So this opposite to 60 is root 3 over 2. And opposite to 30 is a half. So the coordinates of this point is, and notice x is negative, so that's a negative root 3 over 2, and that's positive. So this coordinate here is 3 over 2 negative. The y is positive. And this rotation right here is right around when you hit the here. This rotation, I'll do it on the outside. There it goes. This is the 210 rotation that I just did right to here. So that's 210 degree rotation. This is a perpendicular. Again, 210 is 180 and 30. And this angle is 60. So opposite of 60 is root 3 over 2, but it's negative. Opposite 30 is a half, and is negative because the y is negative. So the coordinates of this point is x is a negative root 3 over 2, and y is a negative a half. And if we rotate all the way around right over to here, then here we go. We're rotating all the way around until we get, so right to there. So that's the 330 that I just did. And 330, this reference angle here is 30. This is a 60. Opposite 60 is root 3 over 2. Opposite 30 is a half. But because it's going down in the fourth quadrant for the y is negative. So the coordinates of these points, x is root 3 over 2, and y is a negative a half. So I put the 4 rotations onto one circle. Notice the coordinates of the point is the cos value of these 4 rotations. The cos is root 3 over 2, but is positive in quadrant 1. Positive, cos is the x, so it's negative in quadrant 2, and x is negative in quadrant 3, and positive in quadrant 4. But cos is always, the cos of the reference angle for 30 degrees is always root 3 over 2, but it's plus and minus because the x is plus and minus in different quadrants. And the sine of the rotation is the y value, and the y value is always a half, but it's positive in quadrant 1, positive in quadrant 2, negative in quadrant 3, negative in quadrant 4. So for the 30 degree reference angle, the values are the same for the x except plus minus depending on the quadrant. The value for y is the same value except plus and minus depending on the quadrant. So that's for the reference angle of 30. Again, just to repeat, when I draw a triangle and I have a 30 degree angle and a 60 degree angle, opposite 30 is a half. Opposite 60 is root 3 over 2 when the hypotenuse is 1, or it's on a unit circle and the radius is 1. Let's look at another rotation. What about a 360 degrees? Or 360 degrees, 390 degrees is this rotation right here. So you go all the way around. Plus, you go 30 more, because 360 off is 30 degree left. So 390 is the same as rotating 30, because it's coterminal. So 390 degree rotation is the same as if you went just 30. So you put 30 there and drew your terminal arm. Again, you're rotating from this point 1, 0, because the radius of the circle is 1. That's a 1 from there to there. When you drop a perpendicular to the x-axis, this 30 degree reference angle, this is a 60, and this is 1/2 opposite 30. Root 3 over 2 is opposite to 60 in this triangle, and the hypotenuse of the radius of the circle is 1. So the cos is the x, which is root 3 over 2. The sine is, that's supposed to be sine there. The sine, sorry about that. The sine of 30 is the y, which is a half. always. Again, when the triangle is 30, 60, 90, 1/2 is opposite 30, and root 3 over 2 is opposite 60. When you have a hypotenuse of 1, or the radius of the circle is 1. And again, this circle got a radius of 1. This point is 1, 0. And we're rotating from this terminal arm is rotating around a negative 150. A negative 150, that's 90. So it's continue on. Negative 150 is right here. So if you take a negative 150 and you add on from 300, you get a 210 degree rotation. So a negative 150 rotation is the same as if you went around this way, 210, either one. So whatever way you rotate, this way, negative 150 or positive 210, when you draw your terminal arm out to where it stops, this angle here is 30. So negative 150, 30 more makes negative 180. Or if you go 210, then you're gone 180 plus 30, perpendicular to the x-axis. Opposite 30 goes 1/2. Opposite to 60 goes root 3 over 2. But in third quadrant, x is negative. In the third quadrant, the y is negative. So the cos of negative 150 is the same as the cos of 210, which is the x, which is the negative root 3 over 2. And the sine of a negative 150 is the same as the sine of 110. And you get negative 1/2, because sine is the y value. Hopefully you begin to see. I always draw a diagram. It helps me. Just quickly, I'm going to do the exact value of the cos of 210. So I quickly draw a circle, draw a rotation. There's my circle. I draw an axis and put the circle on it. Rotation of 210, 180, and there it is. And I draw a terminal arm, 210, and that's 30. Perpendicular to the x-axis, that's a 60. So the cos is the x. So, and that's a root 3 over 2 negative. Opposite 30 is 1/2 and a negative. Cos is the x, which is a negative root 3 over 2. And we go 330 degrees. Again, draw my circle. Rotate 330. It's right over, right around, right around. 330 is right there. And you draw your terminal arm. So that's 310. This angle here is a 30. Perpendicular, 90 degree. That's a 60. Opposite 30 is 1/2. Opposite 60 is root 3 over 2. Hypotenuse, or the radius, is 1. Remember, this point right here is 1, 0. So cos is the x, sine is the y. Oh, we're in the first quadrant. This is quadrant 4. The x is positive and the y is negative. So the sine is the y. So the y is negative 1/2. And tan. Let's draw the circle again. Always draw the circle. I do anyway. And negative 330 is starting here. This is the point 1, 0. Radius is 1. We start and go negative 330, which is right there. Terminal arm. So negative 330. You could take a negative 330 and add on 360, and you'll get a 30. So this is a 30 left right here. So that means that angle is 30. This is a perpendicular to the x-axis. This is 60. Opposite to 60 is root 3 over 2. Opposite to 30 is 1/2. And the tan is the opposite over the adjacent. The tan is the y over the x. And the y could be the sine of negative 330 over x, which is the cos of 330. So if it's the y over the x, or the sine of 30 or negative 330, the sine is the y, and the y is a half. The cos is just root 3 over 2. So that becomes a half times 2 over root 3, because when you divide, you multiply by the reciprocal. The 2's cancel out, you get 1 over root 3 times root 3 over root 3. 1 times root 3 is root 3. Root 3 times root 3 is just 3. So the tan is the y over the x, or the sine over the cosine. And secant, again, I always draw a diagram, put my circle on it. And the rotation of 150 from here, 150 is right to here. Draw a terminal arm. And if that's a rotation of 150, this angle is a 30, perpendicular to the x-axis. This angle is 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. And the y is going up, so it's a plus. The x is going to the left, so it's a minus. Secant is 1 over the cos of 150. So the cos of 150, cos is the x, so it's just a negative root 3 over 2, because the x is negative root 3 over 2, the y is a half. So that gives me 1 times negative 2 over root 3. And that's negative 2 over root 3. Not allowed to have a root in the bottom, so we multiply by root 3 over root 3. So it's a negative 2 root 3 over 3 as an exact value. Okay, let's continue. Find the exact value of the cosecant of 570. So if we have 570, so we take 570 and we take away 360, we'll get a 210 degree. So the cosecant of 570 is the same as the cosecant of 210. And the cosecant of 210 is 1 over the sine of 210. So let's draw our diagram. 210 degree rotation. Again, from the point 1, 0, because the radius of the circle is 1, we rotate 210 degrees, 90, 180, and some more. And when I draw my terminal arm going out through, that's a 210. So that's 180 out of that, gives me a 30. Perpendicular to the x-axis gives me a 30, 90, 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. And because we're in the third quadrant, the x is negative and the y is negative. And the sine of 210, sine is the y, which is a negative a half. So that's 1 times negative 2 over 1, which is negative 2. And we have one more to do, cot. Hopefully everything is getting clear. And we have the cot of 1,050, negative. So let's take my calculator now and do negative 1,050. So here's the calculator. And I got a negative 1,050. And I'm going to add on 360. And I'm going to add on 360. Still negative. I'm going to add on 360. So I keep adding on 360 till I get a positive angle. I call it positive coterminal angle. So adding on 360, I get, that's the same as the cot of 30 degrees. I could go around and around like that, but it's better to go with the cot of 30. So here we go. Draw a circle. So now it's easier to draw 30-degree rotation, which is right here. Terminal arm goes out through, perpendicular to the x-axis. So this is the 30, this is the 30 here, this is the 60. So this opposite 30 is a half, opposite 60 is root 3 over 2, and the hypotenuse is 1. And again, this point right here, because the radius of the circle is 1, this point is 1, 0, and it's the point 1, 0 that's rotating around the circle. So the cot tan is the y over the x, or the sine over the cosine. So cot is the x over the y, or it's the cos of 30 over the sine of 30, whatever way you want to write it down. And the cos is the x, which is root 3 over 2, divided by the sine of 30, which is a half. And so that's root 3 over 2 times 2 over 1. The 2's cancel, and I get a root 3. Notice the exact value. And again, just to repeat, just to remind everybody, it makes no difference where I put the 60 or the 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And the radius of the circle or hypotenuse is 1. And don't forget, when you do your rotation, you have to get the reference angle, and you also have to know if the x is plus or minus and the y is plus or minus in the quadrant. And the cos of theta is the x, the sine of the rotation is y, and the tan is the y over the x. The cot is the x over the y. And don't forget that cosecant is the reciprocal, so cosecant is the reciprocal of sine, so it's 1 over y, and secant is the reciprocal of cos, so it's 1 over x. Just a review there. And that's the reference angle of 30-degree rotation around the circle. If you like my video, click on the like button, subscribe button, notification bell. Visit my website, www.mathsfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you very much. Bye-bye.